Hi everyone, this is Yash,
This is Ahmed.
and this is our Math 354 mini project 2. We have been given the data for fatal accidents from 2000 to 2010, and we have to predict the fatal accidents for 2011. This is the data that was provided to us, and as you could see, there were a lot of missing values and unknown values in the data. So to process those, what we first did was convert all the missing values and unknown values using conditional formatting to NA, and this would provide us to condense the data. And to further go, what we did was there were two things that we did differently. The first one was with all the data that had numbers. So, for example, like age or travel speed. And on the other side, the text data like owner, deformed, and seat position. So, in order to process those, what we do is to process the values with the numbers, what we do is we convert all the NA values to zero and use the formula for average if, and then average the data and convert all the zeros to the average. And another case where there were text values, for example, as we saw, sex, owner. Uh, what we did was we replaced all the values with the mode using this function. So we found the mode for the ones that were most frequently occurring and replaced all the unknown and error values with the mode value. Further going into it, this is how we clean the data, and then to convert the injury severity which we had to predict for 2011, we converted it into binary code of zeros and ones. So to do that, we use the function. If injury severity is fatal, then it shows one, everything else was zero. And this is how we did it. To further go into it, we converted the travel speed and age. Just because they had so many numeric values, we converted them into groups. For the age, we converted them from if they were 0 to 14 to a children, 15 to 25 to a youth, 26 to 45 to an adult, 46 to 65 to an adult too, and 65 years and above as a senior. And then we categorized speed as 0 to 30 miles per hour as slow, 31 to 60 as medium, and 61 and above as fast.
For the model construction, we first started by reading in all the CSV files into R, and for the linear variable and the general linear model, we had to choose out of 28 independent variables, the ones that were significantly explained the variance in injury severity. There were certain variables that could be eliminated out of the model for various reasons, such as vehicle number and person number and case number. These were arbitrary values which were assigned. Then day, hour, minute. They were written separately as different variables, and therefore we couldn't use them in the model. So to choose between the other remaining variables, we used two methods to evaluate whether we would use the variable or not. We used p-value and stepwise regression. So first, the most significant variable using p-value was drinking, as all of the categories of drinking had a very low p-value, and therefore we could tell that they were significantly important in explaining the variation of injury severity. Then, using the steps on the stepwise regression, we found that drinking again had the lowest value as AIC value as compared to other variables. So we used drinking with state, sex, and route in construction for both of our models. Next, in order to test the reliability of our linear model, we randomly chose one of the 4 years to create a model and predict the number of fatal accidents for the other 3 years. In our case, we used the 2006 data to predict the number of fatal accidents in 2009. We achieved an actual and expected value of over 100%, and therefore we could conclude that our model was reliable and it could reliably predict for 2011. Then again, we tested our general linear model using 2008 data to predict the fatal accidents for 2007 this time. And similarly, we achieved a A&D result of close to 100%. So we could reliably say that both of our models were good predictors. And so we've used 4 years of data to create both models and predict the number of fatal injuries in 2011.
We further went into cross validation. So to do cross validation, what we did was we made all the different R binds. We combined all the years depending on. So for example, for the first fold, we had the data for 2007, 8, and 9, and then we predicted for 2006, and then used that data to see how accurately our model works. And then we did that for all the four different folds, and then we copy pasted it in a new Excel sheet. So all those data, all the predictions for all the years are here. And then this was the actual number of fatal accidents that happened from 2006 to 2009. And this was the expected value. And then we achieved a ratio of 99.95621%, which was approximately 100%. And therefore, we can say our model was a reliable model. And then we used pivot tables to identify all the different characters to identify all the different variables on how they were reacting with the injury indicator. And to further go into it, we used the predicted data that we found we used the predicted data that we found in the general linear model to predict for our data in 2011. Thank you.